Welcome everyone to day 10 of Advent of Code. We have finally reached the double digits, so we are doing pretty good. Today's problem involves building a new monitoring station that can observe the most meteors around it. So for our input, we are going to be given something like this. Actually, this is our input, where all the dots are empty and these pound or hashtags here are the meteors. The meteors are actually really small and they exist exactly on the XY coordinate here. So this is 0, 0, 1, 0, 2, 0. Didn't mean to flip that. And the goal of this is to find the meteor that can see the most other meteors. That makes sense. So with the monitoring station, it is line of sight. So from, let's see, from here, this one, it can see this meteor. However, if there was a meteor directly behind it here, it would not be able to see that one. I think they give a good example that I'll put up here that shows the meteor in the top left here with the large numbers or the uppercase numbers as the meteors that could be seen, and the lowercase numbers being ones that would be hidden by that first meteor. Given this problem, I've been able to think about this a little bit because this is actually a conceptual math problem. And what I've come up with for the solution is actually going to be a form of ray tracing. So if you don't know what ray tracing is, obviously there's a whole thing going around about graphics cards, like the RTX series and whatnot, having ray tracing. Well, at the very base concept in computer science, ray tracing is basically just a ray originating from some position. So let's say in the example, originating from that top left corner. And a ray is a line that extends infinitely in one direction, originating from a point. So if we make a ray originating from our meteor in the top left and we infinitely expand it through the A's here, you'll notice that it crosses through the uppercase A first before crossing through the lowercase a's and none of the rest of them. So ray tracing here will allow us to take any meteor in this grid here, throw a bunch of rays around it, and see which meteors they cross with. The difficulty in ray tracing is how many lines do you choose. The more lines you choose, the greater the detail. So when you're talking about graphics, if you have a light source, the more rays you shoot off from that light source, the more accurate your lighting will be. However, in this case, it's not really clear how many we would need. So my plan for this is to use ray tracing, but to do the reverse of it. Instead of it originating from the point here, like this one here, we are going to use this as our origin, but we're going to loop through all of the rest of the meteors and draw a ray from the origin to the one we're looping at. And what we'll do is say we're originating here and we pick this one, we will draw a ray from here to this meteor up here and see if it crosses through any other meteors. That's my goal. I think that's going to be the best way to go about this. And here's hoping that this will work. So the first thing we'll need to do is obviously read our inputs in. So it's a list of strings. This is going to be lines equals file util load file res day10-1.txt. I've also been finding out I didn't need the dash ones. I did the dash ones originally because I thought there would be two inputs for some days, but apparently not. But anyways, so I've already checked my input. My input's a 36 by 36, so we're gonna go ahead and create a 36 by 36 2D integer array. Actually, let's do a Boolean array. This will make it a little bit easier. You know what? I'm not gonna force myself. Let's just do integer because it's gonna be a little bit easier. I'm not gonna force myself to be stuck with booleans. So this is going to be our map. And it's going to equal new integer array 36 by 36. And of course, we have to keep in mind that the upper left is 0, 0. So if you've ever done with computer graphics or game design or game development, you know that upper left 0, 0 is very natural to you. However, if you've never dealt with that and you're more a math person, 0, 0 being in the bottom left makes more sense. You know, it's the left side is still 0, x, but the top in this case is 0, y, bottom is positive. So something to keep in mind. All right, so let's loop through all of the lines here. So for string line and lines, we actually need to, let's do this as integer. So int I equals 0, while I is less than lines dot size I plus plus. Do it this way. That way we can better keep track of what line we're at. That way when we're inserting in the map, it's a little bit easier. So let's do our line here, lines.get I. And now we need to break up this line into characters. That's an int stream. I don't want this. I want to char array. So now we can do for int j equals 0 while j is less than char array. So there's our characters. This is either the period or the pound symbol. And length and j plus plus. I should change these from I and j to row column. So this is the row. Chars is that, but this is going to be the column here. And all we do is in map, we simply just do row, column, and it's going to be equal to chars of column. There we go. So that'll build up our map for us. And now that we have our map, we can go ahead and do our array calculation. So first thing to do is we will, let's see. So first things first, we will have a double list. Is it better to actually have this as a map or better to do a vector? I wonder, actually it might be better if we do a map here, or a list instead, a list of vector. Oh, there's vectors in Java? Hold on, I've never used these vectors from Java. What can I? So it's a vector. Is this just 2-dimensional or is this 3-dimensional or? Interesting. Okay, never mind. I'm not gonna use vectors. So we're gonna make our own vector. So we have a list of vector 2D. I'll call this that. Is fine. Actually, we'll call it 2i because that's more standard. So we gotta go ahead and make this class. So public static class vector 2i. If you'll know, 2i stands for 2, as in there's gonna be 2 coordinates, and like 2D, and the I stands for integer. So int x, int y. Okay, so this is our vector 2i. So this is going to be meteor, our meteors. That's an array list. Okay, so instead of doing this here, we will go through all the lines. So a row is going to be x. So this is our x coordinate. And the columns are our y. Nope, wrong way around. The rows are our y coordinate. And the columns are our x coordinate. And what we will do is we will check if chars x equals the pound symbol here. And if that is true, we will go ahead and add meteors. We will add a new vector 2i. This needs a constructor to take an int x, int y. Let me add public to this. That way it's a little bit easier. Public vector 2i, int x, int y. This dot x equals x, and this dot y equals y. There we go. Okay, so now we have our vector 2i. Add it into the list. Give it x and y. Makes sense. Easy enough. So now we have a list of meteors. So this makes it a little bit easier because now we can just do a double for loop of every vector. So this is going to be origin and meteors. And then for every origin, we will also then have to test it for every meteor. Okay. Okay, so first let's just build our array that goes from the origin to the meteor. So believe it or not, we can actually use vector 2i both as a position and also as a vector, because if you don't know, in game development or anything that uses vectors or positions, a position is just a vector from the origin to the to wherever you want the location to be. So we can represent any array as a vector, so any array for array trace as a vector, and it'll simply be our endpoint, so in this case meteor minus the origin, and that'll give us a array originating at the origin, so 0, 0, or offset it to be at this origin that goes to this meteor. So this will help us out, because what we can do is we can do new vector 2i. This will be our array equals new vector 2i, and it can be meteor dot x minus origin dot x, and then meteor dot y minus origin dot x dot y. Sorry. And now this is our array. Now the only thing left to do is to figure out if this ray will cross the path of any other meteor in this array. So, and back to their example, if we were starting at the top left again at the meteor, if we were say to that third lowercase c, the third closest one, if we were starting at that one and that was our meteor, we have our origin, we have our array that was going from the meteor to that C, we need to figure out if it is crossing any other meteors. In this case, yes, it is crossing the uppercase C as well as two other lowercase c's, and we need to figure out how it's crossing there. So to do this, this is where the fact that we're on a grid makes this a lot easier. Normally, you would actually have to physically go to each one and check and do this kind of calculation again, but we can kind of shorthand it a bit. So since we have an array, we can get all of the specific coordinates it crosses by just finding the least common multiple of the x and y. So basically we're finding the slope of the line. So in order to do that, we need to make another method called it's going to return return a vector 2i. This is going to be our slope. This will be find slope. I think I said least common multiple. Is that right? I don't know if that's right, but it's greatest common factor is kind of what we're actually going to be going for, or either or, I guess. I shouldn't be thinking about math right now. Anyways, so this is the find slope of our vector 2i. So this is going to be the line, or I guess we'll just call it the array. That's fine. So we need to find the greatest common factor of these. Okay, so and then to find the greatest common factor, if you didn't know, I had to look this up just to make sure, but there is a algorithm called the Euclidean algorithm, which is the most, or it's not, I don't know if it's the most, but it's a really efficient way to find the greatest common factor. So let's implement it here. Of course, it's gonna be a little bit different because I'm doing this a little bit different, but it starts off with the array dot y equals 0. Honestly, I'm just gonna be copying this. Actually, I'm going to change this up a bit. I know this makes more sense because it's in terms of two. I'm going to change this up. We're going to do it literally as the Euclidean algorithm. So in this case, then we return x, return x. Otherwise, we return the find GCF of y, comma, what is it? A percent y. Sorry, I had to think about that for a second. And this returns an integer. Okay. All right, I had to look at it. Wanted to make sure. I wanted to make sure. That's funny. Thinks it's wrong. So I just wanted to make sure that I was doing this correctly. So int, so this is the greatest common factor, is going to be equal to this method. Pass it our array x and our array y. And what we will do now we have our greatest common factor, is we will actually adjust array x and y to be the same, just divided by the greatest common factor. This will give us our slope, array y. So now we have our slope. Now what we can do is, using this slope, we can visit every single location on the grid between our origin meteor and our regular meteor and see if there exists a meteor there. So we will do for try to think here. So I guess using greatest common factor, that would be how many steps, right? Yeah, so it'd be that many steps to go from the origin to this meteor. So I'm gonna, let's verify that's correct, but for int I equals 0, while I is less than the greatest common factor, I plus plus, and we will do a system.out.println. Let's just verify this works. Checking origin. Let's write a toString method here. Public void toString. Oh, public void string toString. That'd be helpful. Return x. Return that. That should be a good return for toString. Public void string? No, public string toString. There we go. What? That override. There we go. All right. So now there's our origin. And let's then also output the meteor. And then lastly, let's output our check. And our check will be array x. Let's do this. Array.x. So this is the location we are checking. We'll be checking array.x times I plus the origin x. And then the y is the same thing, just with the y's. And let's just verify that we are checking the correct locations and all that fun stuff. Let's go ahead and run this. Let it build. And please divide by 0. Oh, if the GCF is 0, that means it can't be divided. Oh, okay, wait. So if GCF is, whoops. Although it shouldn't be, I guess it can be 0 because if it's a 0, 0. Sorry. Run that again. Okay, so the origin is there. Interesting, that doesn't seem right. It's checking that. That's not right. So 33, 35. It should be checking 2 locations. Let's be like that. Oh no, that's right. There we go. Last one. Oh yeah, okay, there we go. Yeah, they did it. So now it checks. It'll check the origin. So honestly, we should start at start at 0, but then increment I, so that way we are always going to be checking the one after. We don't want to recheck the origin. So now we should see it only check it once down here, but check the ending spot instead. Okay. Okay. Or should we start it at 1? That way it won't check the ending and it won't check the beginning. Because we don't want to check either. We only want to check what's between the 2. Not either ends. We want to check the origin or the meteor's location. That looks right to me. Okay. Alright, so now we are checking each location. So what we want to do is we need to add an equals method. So we need to override public boolean equals. This is going to be object. Make sure that it's an instance of vector2i. If it's not, return false. I don't know what that one is. I just put on the sidebar here. What's a bookmark? I've never seen a bookmark before. Otherwise, it is a vector2i, so we can do vector2i vec equals object. So cast our object to a vector. And now we will simply return vector.x equals rx and vector.y equals ry. So that is how we will check if the 2 vectors are the same. So now that we have a location here, we need to keep a map. So we have a list of meteors, so we need to do a map of vector2i and integer. So this is the amount of meteors that can be seen. Or actually, no, screw it. We don't need a map. We can just keep track of the largest one. So vector2i, so current largest equals new vector2. Doesn't really matter. We can just start at 0, 0 is fine. Int most meteors visible. We'll do -1 to start. That way everything will always be greater than. And what we will do is every time we go through a meteor, we need to do an integer check. So this is meteors visible. And here we'll do a check. So if our meteors list does not contain this location that we are checking. So in this case, here, so if our origin is this location, our meteor is here. The only check is being run at 34, 31. If the meteors list does not contain this XY coordinates, which it doesn't seem it does, then it says that this meteor can be seen by our origin, in which case we will increment the number of meteors that is visible. And lastly, we will check to see if our number of meteors visible is greater than largest or current largest. If it is, nope. If it's greater than that, if it is, we set them equal, and we also set current largest equal to our origin. In which case, at the very end, we will do a system out print line part 1, and we will output, I think it just asked for the number. Or what does it ask for? Yeah, just the max number, but I'll do both. So I'll do part 1 there, and then at that location, it can see this many meteors. Give it a run. Fingers crossed this works. From 1, 0, let's make sure that's a location. It is. It can see 643. Unfortunately, it's too high. So now comes the fun part of trying to debug this and figure out here. Okay, so let's do a system. Oh, what we first need to do is we actually need to check. Oh, wait. We're incrementing the wrong spot. We only want to increment here. We have to do a Boolean visible. I see what's wrong. So we were incrementing every step. However, there is not a meteor at 2, 0, which is right, but it's incrementing for the meteor 8, 0, which is like what, here? That's the issue. We were incrementing every time this failed to find a meteor, but this is just checking to make sure there isn't a meteor there. So all we do here is we set visible equal to false, and then out here only increment it assuming that it is visible. Gotcha. That helps out a lot. Okay, let's give this another run. And we can see 325 from this meteor's location. But the answer is still too high.
At night was born to find mythical, so mystical, think what you like. You could be the sword, the shield, defender of the people down below. You know I fall for love. You know I fall for love. You know I fall for love. Be kind to those around you, don't be merciless. Remember
Okay, I'm back. It's literally like an hour and a half since I stopped. Oh my goodness. So, what was the issue? The biggest issue was that GCF, you can't take the GCF of negative numbers. I don't know why that didn't come to me sooner, but because the array here, you could get negative numbers. If you find the GCF of negative numbers, you're gonna get weird answers. You're most likely gonna get like a -1 or weird stuff like that. That was the biggest issue, was that GCF was taking the, well, I wasn't giving it positive numbers. The second smaller issue was that this was flipped around. I should have been checking, like it is right now, I should have been checking first and then updating location instead of updating location and then checking. Yeah, honestly, if I had thought of that sooner, this would not have taken me long. This honestly would not have taken me that long. I don't know how much of the debugging process I'm going to show, because honestly, it was a lot of just trial and error and trying to figure out what was actually happening. But at the end of the day, I had the right idea and I had everything right. This for loop could have been I could have done a for loop anyways. But I ended up just going with a while loop in the end. So yeah, in the end, those were the issues. Again, it's just, yeah. So I got part 1 right finally. So let me read part 2 and I'll get back to you guys on that. Okay, so part 2 is a little weird. So basically, we are now vaporizing the asteroids by a giant laser. The laser can only move clockwise. It can only vaporize one asteroid in a line. So like if the laser is pointed up and there is directly above the asteroid, there's an asteroid and there's one behind that, it can only vaporize one per rotation, if that makes sense. Or one, yeah, in a direction at a time. So the goal of this is to figure out what will be the 200th asteroid vaporized. Yeah. So let's see. Honestly, what we could do is, while we're going around, or what we can do is we can do a similar thing we did here. So if we use this for part 2, so we have the asteroid that's going to be, we have our origin, so vector to I, so this is current largest, will be the one we're using instead of origin. So current largest, that, there. So what we can do is, instead of tracking visibility, we just need the angle at which the asteroid is. So what we can do is we need a map of let's do a map of vector 2i, because this will be the array up here, and then we'll do a list of vector 2i positions. So this is going to be the asteroid lines, I'll call them. I don't know. New hash map. Oh wait, but vector 2i needs a hash. Okay, never mind. Let's instead, okay, that's fine. Let's just do what we did last time. Let's just override the hash function. Let's just override this and return x times 100 plus y. Basically, we did that before. So now it should be able to hash them correctly and figure out which ones are the same. Okay, so here's the asteroid lines. So this is actually going to go out here. So now we have our array. We don't need to know what ones are in the way. We just want to care about how far it is, because how far it is will determine where in the list it gets put. So the array is what we want to use. So we want to do asteroid line. So we have list vector 2i. This is going to be the asteroids in the line. Asteroid lines dot compute if absent. Okay, we should return a new abstract or a new array list. Right? Hello? What? Oh, well, oh, you know what we're missing? We're missing the key. The keys array. That's what we're missing. Haha, I'm smart. Okay, so now we have our asteroids. So all we care about in this list is distance. So we do, let's do a check. So if asteroids dot size, or no, int I equals 0, while run. No. While I is less than asteroids dot size. Let's grab the vector out. Vector 2i equals, this is going to be the asteroid dot get I. Okay, so what we will do is check. So this is the location it's at. We need to figure out how far this asteroid is from the array. And that's actually simple because all we do is we divide. So we can just do distance. So double dist equals math dot square root of math pow. Actually, can we just add it down here? No, not there. Public double distance 2 vector 2i. We can actually just return vec. So it's going to be the vec dot x minus the x of this one, math dot pow. This will actually suffice. We don't need to square root it. Vec dot y minus y2. This should suffice for checking. We shouldn't need to do the square root. This should suffice for checking for distance. So all we need to do is double asteroid dist. Where is our distance? Our distance, so it's not current distance, it's actually just meteor dot distance to that. If that's larger, then otherwise we just increment I, and then wherever we end up I is, we simply set asteroids dot, it's not set, to set push things. No, we want add, and then just add I. Add to I our current meteor. Okay. So the only issue here is that this is going to make sorting harder. So instead of vector 2i, let's do, you know what, we can just sort this, can't we? We could probably just sort this later. Okay, so this will stack all of the asteroids into correct lines. So what we can do is then we can then do our, so I need to make a comparator. Okay, this is just getting more and more fun. So public comparator vector to I. So we're given these two, so we need to compare them by angle. So this is going to be angle compare. So for this angle compare, we need to do some trig. So what we need to do to find the angle, so this is going to be double O1 angle is going to be equal to math dot, what's it, tan, or arctangent of O1 dot x divided by O1 dot y. All the way around. And this is going to be math. This is going to be integer logic, so I need to cast one of them to a double. That way it's doing double logic, or it's going to give us a decimal place instead of doing it as integer logic. Do this for O2 as well, and then simply return O2 minus O1 angle. Oh, let's just do double dot compare. Let's do it this way instead of rewriting our own. To angle. Okay. So here's our compare method. We can actually replace it with lambda just because it wants to. Okay. So here's our compare. So once we do this, we need to sort through these. So this is going to be sorted vectors. Can I just pass it the map? So asteroid lines key set. Can I just pass it like that? I can. So I can do now sorted vectors, sort, give it that sorter. Now it's sorted. So what we do is we do for so we're gonna do a count. So int destroyed equals 0. So now we do for vector in sorted vectors. Now we're just gonna go around through all the vectors and keep looping through it until we hit destroyed as 200. And how we do this is we go to the asteroid lines, we get the vector, we save it to a list. So this is going to be, again, asteroids. We will skip it with asteroids dot size does not equal 0 is when we do logic. And then what we do is we will then remove 0 and we will then increment destroyed. And then if destroyed equals 200, we will break out of this. And we do need last destroyed. Last destroyed. We do need to then, no, we don't need to do that. We can just set last destroyed equal there. And last but not least, we just system out print line. And because I made the hash code what they are asking, let me make sure. Yes, I made what they're asking. So we can just simply output last destroyed dot hash code. Let me put in part 2 in front of it. So part 2. And there we go. 406 is what I got. Please tell me that's right. It's not right.
The stars align. A night like this can never rewind. Can you hear the wolf cry out to the light? A night like this and never shine so bright. So take a couple steps back as you hear me start to hum. Take a couple steps back when I lose all control. Watch me turn into a werewolf, and I will haunt till the break of dawn. Don't you dare to try to stop me. This is the heart of the black swan. So take a couple steps back.
Okay, I think I have finally gotten it to where it's the compare to is now going counterclockwise, starting from 0, -1, because that is our up direction. Don't ask. And I think, oh, that'd be our answer then. 14, 17. Please, please, please. Yes, that's right. Okay. Well, that was fun. Not really, but there we go. There's our code. Oh no. Yeah, today was not very fun. I don't know how this video is gonna turn out because I spent like 4 hours trying to do this. Today was not a good day. But yeah. So I would try and summarize the code, but I'm just gonna leave it there. Today's video is definitely not very good. Hopefully I can at least make something out of it. The theory behind part 1 was, I think, the right way to go about it. And I think the theory of part 2 is also a good way to go about it, but the math is what tripped me up, and I just didn't get the math correct to where my theories were actually rolling correctly. Anyways, that's day 10. That is day 10 done. I want to also add that on the GitHub page, I've also added day 1 written in Scheme. It's like a version of Lisp, of Common Lisp. If you really care, that's up there. And then I also have done the Encode program. I've implemented it for like days 2, 5, 7, 9. I think these are the days. They all use the same Encode program class. But yeah, so hope you guys enjoyed today, and I'll see you guys all tomorrow for day 11.